Afternoon session for increasing safety by CERTIUM analysis, test and measurement solutions. I will have this presentation together with my colleague Jindrich. He will come on stage soon. So I will do the first half and he will do the second half. So just to give you a short idea of what I will be talking about. So my field is the navigation field, and I will talk about field analysis, lab measurements, and signal generation. Later we will come to communication tests, and this is what Jindrich will do for us. So first of all, if you're looking at ground and flight inspection for terrestrial navigation signals, we're normally looking at signals like typical ILS or VOR or DMEs or whatever. And I would like to start now with the ILS and VOR and G-bus signals and depart that into ground inspection and flight inspection. So for the ground inspection, you normally use, for example, a lift-up mask to measure the ILS light slope, or you use a car to measure the localizer. We have an instrument for this called EVSG 1000. It's a box that is able to do all the measurements for ILSs, VORs, macro beacons, G-buses, and non-directional beacons. It's a battery-powered unit, and you can work with that unit up to 8 hours without main supply in the field. It allows you to do manual measurements, so you use a weight or a mast, and you can also install it in a car. But ICAO Doc 8071 says that all measurements have to be also done via flight inspection. For these purposes, you normally use a small plane, like this King Air, or you also can use a drone to do measurements in the field. For these two applications, we have also a box we call EVSF 1000. And this is more or less the brother of the EVSG 1000. So the hardware inside, the RF hardware and the signal analysis capabilities are the same. But the look and feel is, of course, very different, because the EVSF for measurements aboard of a plane does not need a big display, does not need a keyboard or an internal battery. But the accuracy and the comparability of the measurements is very good. On the other hand, we have also DME and TACAN signals. These are pulse navigation signals. And for these, you do also, for example, measurements in the field with a directional antenna like shown here. And for these, we have two instruments that can be used for that. Also one for flight inspection. This is the EDS 300. And we have also a box that can be used on ground and has a built-in battery. We call it EDS T300. So if I go a little bit more into detail and tell about the key facts of these instruments, you see here that we have an instrument that is a high-precision analyzer for all these signals that I mentioned before, according to ICAO Doc 8071 and Annex 10. And in fact, it's a high-precision level and modulation analyzer that is able to record all the data internally or to stream the data out via LAN and do also IQ data recording. As I said before, the brother is the EVSF. This box is built and made to be built into flight inspection systems. So it has the same hardware inside, but we offer, of course, accessories that make it usable for flight inspection, like, for example, a tray for integrating that into a flight inspection plane. Due to the high sensitivity and accuracy of the device, you can also do coverage measurements and do really measurements over very long distances. As I mentioned before, we have the EDS 300, a box that can measure up to 10 DMEs in 50 milliseconds. So it has a multi-DME mode, as we call it. And this is available with two different levels of power. So So with a 20 watts interrogator that can be used for very small areas, and a 500 watts peak interrogator that can be used also for 200 nautical miles distance measurements. This is all built inside the box. We have a box for ground, looks the same more or less, but has an internal battery and can be used also for TACAN measurements. If you want to do your angle measurements for the TACAN in the field, you can use EDST for that and do your DME or TACAN measurements. So these boxes were all made for field measurements. Now what about lab measurements? So in the lab, of course, you have different applications. You do not need the battery and you need high precision. Normally you measure cable-wise. So we have analyzers for that. For example, here it's a FSW, which is a spectrum analyzer with a special option. You can also do the ILS and VUR measurements. We have, of course, scopes like the RTE here that can be, for example, used to measure the pulse shape of a DME, so rise time, fall time, pulse width, pulse spacing. And we have for field measurements also other instruments than for terrestrial navigation, so general purpose spectrum analyzers. And we have more or less, I listed here four. We have the FSH, FPH, ZVH, and ZPH. So these analyzers are spectrum and network analyzers to do, for example, measurements on antennas, distance to fault measurements, or interference hunting, or also vector voltmeter measurements for installing ILS antennas, for example. So if we look a little bit more into detail for these devices, I will start with the FSW, and I will not go through all the highlights of the FSW. It also has, of course, a huge frequency range and an excellent phase noise. But what is interesting for us here is it is an analyzer that really offers a super high precision ILS and VUR analysis, and therefore can be used as a reference receiver, for example, in your lab. The RTE is a scope that is really capable of doing a lot of things with a huge bandwidth. And again, for you here, I think the most important thing is that you can do, of course, pulse shape measurements on DMEs or TACANs. Coming to signal generation, one word to that. I forgot to say, I didn't mention here the handheld analyzers because Jindrich has some slides for that, so I didn't want to double that. So we will hear from Jindrich in a minute about the handhelds. But for signal generation, we also have different instruments or power measurements. And you find that all, what I just telling you about, you find that all listed in the new brochure for CERTIUM analysis. And in that brochure, we list all these instruments and we list also the applications that they can be used for. So going also here a little bit into detail, I would like to start with the SMA100B. This is a signal generator of the analog world. So it has excellent harmonics and has a maximum output power of 30 dBm. And it allows you to also generate your ILS and VUR signals if you want to have that in your lab. For example, to test your onboard receivers. We also have a vector signal generator, which is called SNP-V100B. With this, you can not only generate the nav-aid signal that I just was talking about, like ILS and VUR, macro beacon and G-bus. You can also generate the G-bus, the DME signals, and you can simulate GNSS signals like GPS, GLONASS, Baidu, and so on. In combination with a power sensor, you're able to more or less simulate a complete DME ground station. and connect that to the ground station. And the other end of the power sensor can connect to the signal generator, and then have a closed loop measurements for your, for example, main delay. That more or less brings me to the end of my presentation. I would like now hand over to my colleague Jindrich. Did I speak that correct? I first hand it out there to you, and then I give that to you.
So we just hand over the micro. So thank you, Klaus, for the introduction on the navigation test and measurement equipment. And I will speak about the test and measurement for the communication infrastructure. And we have systems for radio and test and calibration. We have systems for interference hunting, and we have also one very interesting product for the quality assurance. So we cover actually with our test and measurement equipment the entire communication chain. So we have a system to monitor the network, the Road Trans-Aqua, which actually partly includes also the IP side of the VCS. We have the CMA 180, which is actually the market standard for testing the radios. And we have the ZPH. This is a perfect device for testing the antennas, testing the antenna cables. Then we have a PR200. PR200 is a monitoring receiver which receives the entire 40 megahertz spectrum, so you can monitor the entire ATC communication band at once. You can record it, and you can also use the system for automated interference hunting. So you can drive around, and the system shows you in 5 minutes very exactly the source of the interference. And of course, the PR200 can be also used, the CMA 180 can be also used for the airborne radio calibration and tests. So let's go through and let's have a look on the CMA 180 first. So it's a, as I said, industry standard for ATC radio and navigation instruments. It supports both analog radios, but also digital and voice or IP radio. It covers the entire frequency for the navigation and communication. And very interesting, you can run in this CMA run in the automated mode. So you actually can send somebody to the radio side, he connects to the radio, press a button, and at the end gets a report of all the test results as a PDF. This is something you can save for further use and use it for recertification of your infrastructure. Then if we have a look on the ZPH, it's a handheld test and measurement device, so you can test antennas, you can also do some, I would not say basic, but very interesting spectrum measurement and signal analysis. You can also use the device for interference hunting. So there is also interference hunting functionality inside. It's not so advanced as within the PR200 on the next slide, but it's already quite good. So you can use a directional antenna and find the source of the interference. And you can do the distance to fault measurements on antenna or the antenna measurements. Then we have the monitoring receiver, the PR200, and this offers a gapless spectral monitoring. So you can completely record the spectrum and automatically identify and locate any kinds of interferences. And as I said already, the system can monitor the 40 megahertz at once. So you don't need to requeue, you can monitor the entire ATC spectrum and look through all the channels you need for the communication. The system can be automated, so there is a omnidirectional, or there is a directional antenna, which multi-directional antenna, which you can put on the roof of our car, and then software where you see the interference is coming in, and it shows you on the map automatically where the interference is located. And also it removes all the multi-signal propagation. So even if in a crowded environment, like within the city, you are able to find the interference. And finally, Rohde-Schwarz-Achbar. Rohde-Schwarz-Achbar is actually IP and RF monitoring system, because it within the RTP data we get from the radios, there are very interesting HF information, like the radio signal strengths. So we can also do a long-term signal and spectrum monitoring using Achbar. So it's a non-intrusive audio quality assurance system for both ground route and M-route communication. So it means it gets a copy of the traffic in the network and analyze just this traffic. So it looks on the IP, on the zip and RTP data, and like from the pattern, packet loss, it calculates the audio quality. It stores the audio quality also for further analysis. But as I said, the RTP data includes also the radio information. So they include like the signal level which is received on the radio. And the radio sends this information every 200 milliseconds, so pretty often. And this allows us to provide you long-term signal and also long-term noise monitoring. So we have, for example, one customer who was very interested to understand in the far north how the noise level are developing throughout the time, because if there are some eruptions, there could be very interesting patterns there. But the system also gives you more information about the channel itself. So it has a PTT and squelch histograms. So how often do you have a PTT? And again, this is something which can be can show you some problems in the RF channel. So for example, at one of our customers, we found an issue where typically he has about 5 PTTs per minute, and then we found a peak of 200 PTTs in a minute. So where those are coming from. So we actually found out those were interferences on the RF channel coming in, causing the radio to open squelch, sorry, those are squelches, open squelch 200 times in a minute, and we zoomed in and found out those were not in a minute, those were in 5 seconds. So those were in 5 seconds, 200 squelches. And with this system, you actually get the statistics and you know, okay, what you look for. And then you can use one of the more performant analyzed systems like the the PR200 to look exactly for the source of the interference. In this case, it was a transformer from the electricity company. And one very interesting feature is the loopback monitor. And this is a feature which is really unique in the market, and we patented this feature. And this works in the way that your typical infrastructure is you have a BCS, you have a transmitting radio, and typically the receiving radios are located on a narrow side. And that means that every single transmission on the TX radio has to be followed by reception on the receiving radios. And the receiving radios send the signal back to the BCS, and the Achbar system, the probe, get a signal of both. And we know that every single transmission must be followed by the reception. So we actually correlate the transmission with the receptions. And if you find out that there is no reception, then there is a problem. There is a serious problem because the transmission did not go out. And as we have the signal level also, we look if the signal level remains the same over the time. And from one productive installation in a real scenario, we see that the variation of 2 dB are already a problem. The signal is very stable over the time, so variation of 2 dB are directly directly indicating there is an issue on the radios, or not on the radio. It's maybe the antenna, it's maybe the cabling, maybe a water in the cabling. And this is something which significantly reduces the need of going on site, doing maybe like a monitoring flights, because you get this on every single transmission done by the controller. And this is the very brief overview about our test and measurement systems. Do you have any questions to this? No questions? If you are interested to see more, you can join us in our booth. We have all the systems, or not all, but we have the AFPA, for example, there is a demo. Klaus has one of the systems also there, so we can give you a very nice demonstration. Or you can get in touch with us, and we also can do some afterwards demo on whatever equipment you're interested in. So thank you for being here, and see you in our booth.